So, hello friends, welcome back to C4U. Today's reaction is about benzoin condensation. We will see the reaction and mechanism of benzoin condensation. In last video, I told in benzoin condensation, this kind of a product is formed, which we call as a benzoin. Okay. So this is the product which we have to form, and this product is being formed from benzaldehyde. I will write its full structure. In presence of alcoholic KCl. Two molecules of benzaldehyde reacts with each other in presence of KCl to give benzoin. This is water basic reaction. Now the speciality of this reaction is we saw many types of aldol condensation reactions where something like this or ketones forms anion here, like your enolate. Okay, and these things then attack on other carbonyl to form a condensed product. But in this reaction, you don't see any such a center to form an anion. This carbon forms anion here. This is what the speciality of this reaction. Now how it goes, we will see it. This reaction has the most important role of Cn-, cyanide, which starts the reaction and which ends the reaction. It has three roles in this reaction. We will go one by one while looking to the mechanism. Okay, now let's start with the mechanism. So here is the mechanism. One molecule of benzaldehyde, COH, with Cn-, cyanide attacks on carbonyl, cause this bond to open on the oxygen and gives you this kind of a thing where O-, Cn and H. Now this is the special step of the reaction where oxygen catch up this proton and the negative charge is being formed here. What you will get is a benzene ring with a carbon at benzylic position which have OH, Cn and carb anion. Now this is only the reaction where oxygen takes hydrogen from carbon and causes it to have an anion. The reason is the stability of this carb anion. This negative charge is being stable by the resonance from cyanide, which is a strong electronegative, which shows a strong electronegative resonance effect. Electron withdrawing resonance effect, we call it as. Okay, so this was just to explain the stability. Now what happens? Now we have C anion, which is a nucleophile. We have an electrophile, which is nothing but another molecule of benzaldehyde comes into the picture here. So here I will write it as benzene with COH. This carb anion will attack on your carbonyl, and what you are getting is a condensed product, carbon-carbon with O-, H and pH, let's say. Then carbon, OH, pH and Cn. Okay, then what happens? Yeah, I think we have to go on the another side. No problem, I will write it here. Carbon, carbon, this is what the condensed product. Then O minus, OH, H. This is the proton shift from oxygen to oxygen to just provide a driving force for the next step, which is removal of cyanide. With the removal of cyanide, you get a benzoin, PH, OH, double bond O and PH. This is what a benzoin, as we saw in the case. Now, sorry. Okay. Now you can see cyanide plays an important role throughout the mechanism cycle, where the very first cyanide acts as a nucleophile. Then what it does? Then cyanide stabilizes your carbanion. It stabilizes carbanion. And then at the end it leaves out to give a final product. So it acts as a good leaving group. So these are what the roles of Cn minus in benzoin condensation, which is a very important thing to give you this kind of a thing. Yeah. Now benzoin condensation plays important role in which cases, if you are solving something using retrosynthetic strategies and you will be asked to design a synthone for say this kind of anion. Like if you are supposed to prepare this kind of anion, in those cases the benzoin condensation plays a very important role. Along with this, there are some Umpolong methodologies and many other, but benzoin condensation is a very important reaction in point of view of let's say MSc exam, then yeah, for IIT JAM also, and for JEE advanced and mains. Okay. Now we will go with one problem. Benzoin condensation is typically a condensation between an aromatic aldehyde, let's say ArCOH, with cation, alcoholic cation. It would give you ArOH and double bond O. As like acetylene condensation, acetylene condensation was with aliphatic esters with metallic sodium in any of the solvent like toluene and benzene, or in some cases alcohols are also used. What you are getting is OH and double bond O. If you are supposed to form alpha hydroxy esters with aromatic substitutions, you have an option with benzoin condensation. And if you are supposed to produce, or if you want a product with alpha hydroxy ketone with aliphatic alkyl groups, then you have the option of acetylene condensation. Okay. Now any aromatic ring you can take here. For the sec, I'll go with para-anisaldehyde. Okay, with cation, alcoholic, so you can directly write the product, I guess. For practice, you can do mechanism on yourself. So I will write it in this manner. Okay. OME and OME. Here again you are getting the product which is something similar to the pinecolon reaction, Okay, now for your practice, here is one question. If I have to form if I need this type of a compound, then is it possible to get, or whether what kind of a reagents, what kind of a starting materials you have to use, and what are other possibilities of products being formed? This is what you have to do. This is the question for you. I will come up with its all answers and mechanism in my next video. Till then, just enjoy your chemistry and stay tuned. Thanks for watching this video.